Hi, this is the Unit 4 review video. If you look at this first problem I'm going to show you kind of what I consider the important problems. And this is going to be a really quick video because I need to go ahead and finish up some other things, and I want to make it just quick and relevant for you. If you look at number 3, it says week 1, 2, 3, and 4, and the money change for each one. So between 21 million and 13 million, there's an $8 million drop almost, or a little bit over that actually. And then you see about a 6 million and then a 3 million drop. So in other words, the only one that makes sense to start out high and then kind of jump low and then jump a little bit lower and kind of decrease its change every time is B, because on your graph, if you're looking down at number 3, you see the first point is very high and then the next one is lower, and then you don't see a straight line, which is kind of characteristic of the difference in 8 and 6 and 3. So moving on. Okay, if you look at number 4, what we have, it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Number 4 specifically says, which of the following tables represent the relationship in the diagram above? So really quick, what you maybe don't see is you don't see this 7, or I'm sorry, not the 7. You don't see this 5 because this side is 5, so this side also is going to be 5. This side is going to be 7. This side is also going to be 7. It's going to be 5 and 5. And this is going to be 5, this is going to be 5, 5, and 7. You can kind of fill in some missing sides. So overall, I'm going to put this in green. But overall, if you were to look at the perimeter, the distance around, you got 5, 7, 5, and 7. That's going to give you a total of, where am I at? 14. And, okay, so that's going to give you a total of 24. Sorry, I lost my trace. That's the perimeter, not the area inside. Okay, it's the perimeter. Then you add up all these, 5, 5, 7, 5, 5, and 7, and that's going to give you a total of 34. Then you go ahead and add up all these, 5, 5, 5, 7, 5, 5, 5, and 7, and you're going to get a perimeter, again, of 44, which matches up with choice B. Keep that in mind for the next one. Okay, so number 5, it just says which of the following graphs represents the relationship described described above, which is from the previous problem. So the only one that makes any sense in terms of the actual graph is actually D. So if you just look at like which one lines up with that, the choice is D. Okay, looking at number 10. In blue, I put down all the ordered pairs. It says that those ordered pairs represent a function. What is a rule that represents this function? Explain why it works. So really quick, what I did is I jotted down 1 to the third equals 1, 2 to the third equals 8, 3 to the third equals 27, 4 to the third equals 64. And every time, it's this x value to the third power, x value to the third power, x value to the third power, x value to the third power. So your function rule is simply y is equal to x to the third power, because whatever value you put in for x, if you raise that to the third power, you'll get the y value every time. Okay, so that's y. Okay, if you look at number 12, y equals 3x minus 1, what is the graph of the function rule? Well, first, you have to do a table of values. And I'll do the table. I won't graph it because we've done that in class, but I'll at least do the table for you. You start with x. You put, you can either just do y, or what I like to do is do x comma y, because that's going to give me a point. And I put my function rule in. So y equals 3x minus 1. You're really going to use that piece right there. You put in your own values for x. Okay? Typically, these will work well. -2, -1, 0, 1, and 2. If you go ahead and plug it in, I have 3 times -2 minus 1. Well, 3 times -2 gives me -6. And then I minus 1 from that. And I get -7. So I put in -2. I got out -7. That's my ordered pair. That's one. The second one I do 3 times -1 minus 1. That gives me -3 minus 1, which gives me -4. So I put in -1. I get out -4. That's my second line. That's another point on my graph. If I take 0, 3 times 0 minus 1, oops, kept that in red there, I'd like it in blue, equals, I have 0 minus 1, that gives me -1, so I put in 0, I got out -1, I have 3 times 1, I'm minus 1, and that gives me 3 minus 1 equals 2, and so I have 1 comma 2, I'm going to skip a step here, careful, 3 times 2 minus 1, sorry, equals 6 minus 1 gives you 5. So I put in 2, I get out 5. Those are all my points in my graph, and actually that graph gives me a straight line. Okay, if you look at number 14, it says a produce stand sells roasted peanuts for $1.15 per pound. What is the cost, C, of P pounds of peanuts? Really quick, so $1.15 is right here, 1.15, times by the number of pounds of peanuts is going to give you your actual cost. So that's my actual equation. That's why. It's continuous data because you can buy part of a pound of peanuts. Remember that continuous, you can buy parts of pounds or parts of things. Discrete, you can't. So like you can't buy part of a, you can't buy like half of a DVD. You can't buy half of a phone. Number 15, I'm not going to do this whole thing, but I will explain what absolute value is. So if I do my table of values, because again it just tells you to graph it, you have to do the table first, and I plug in my values. So the absolute value of negative 2. Well, the absolute value of 2 is simply 2, like when you take it out of the absolute value symbol. So instead of saying absolute value of negative 2, I can just write 2 minus 2, and that gives me 0. That's pretty simple. However, what you do need to be careful with on all these is that a negative will make a positive. However, a positive, a positive absolute value, this is also 2, so this actually gives me 2 minus 2 is also 0. So what I get is I get 2 comma 0. So just be careful when you're doing this, that you make sure that you do the absolute value to be even a positive value. So for instance, with 0, 0 happens to already be, you know, a positive value. I could do 0 minus 2, and that's going to give me negative 2. So 0 comma negative 2. And you can fill in the negative 1 and the 1 as well. And then it will form a V on your graph. Okay, number 16, we discussed this one in class, so I'm going to skip that. But essentially, you make the table of values, be very careful with it, make sure you use your calculator. Okay, number 17. Number 17 says, a snail travels at a rate of 2.08 feet per minute. So we're going to say d of t equals 2.08 t. So 2.8 t, so the minutes is t, and the d of t is going to be the actual distance. Okay, so that's the rule. And then how far will the snail travel in 7 minutes? You simply put 7 in for t, and 2.08 times 7 gives you 14.50 or 0.56 feet. Go snail, super fast. So 15.46 feet. Okay, number 20 says, identify the mapping diagram that best relates to the relation and determine whether the relation is a function and explain why. So if I have, and you can read that, that's why I just said it so fast. If you look at the ordered pairs, you see negative 8, negative 6, negative 5, comma 2, negative 8, comma 1, and 7, comma 3. So real quick, I'm going to go ahead and put in order and not list one more than once my domain values, the x values. So negative 8, negative 5, and 7. Again, negative 8 was listed twice, but I'm only going to list it once. Then I have negative 6 for my y value. Next is 1, next is 2, next is 3. Now I need to go ahead and make sure I labeled domain and range. I need to make sure that I go from my negative 8 to my negative 6, that those are paired together. And remember this, negative 8 is also paired with 1, and negative 5 goes with 2, and 7 goes with 3. This right here, folks, is the issue. I have more than one arrow going out of any one domain value, so this relation is not a function. Number 21 says the function f of x equals 44x, or j of x actually equals 44x, represents the number of jumping jacks you can do in x minutes. How many jumping jacks can you do in 20 minutes? Well, seems obvious. You just simply put 20 in place of the x and evaluate it. And 44 times 20 gives you 880 jumping jacks. Okay, the only thing I want to show you on number 22, I think this is all you really need to know, is it says you have 8 cups of flour. that you can use, and it takes 1 cup of flour to make 24 cookies, and it gives you a bunch of other stuff about a function, and you got to decide what's a reasonable domain and range. Well, domain relates to the cups of flour, and range relates to the amount of cookies you can make. And it simply asks you, okay, what's a reasonable domain? What's a reasonable range? When they talk about the domain, you're talking about cups, and you have 8 cups to use, which means that when you're baking, you could use 0 cups, you could use 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, all up to 8 cups. Could you use 9? Absolutely not, because you don't have 9. So a reasonable range is simply that 0 is less than or equal to f, and f is less than or equal to 8. So it's in between 0 and 8, including 0 and 8. The range then kind of works the same way. If you use 0 cups for the range, you're going to get 0 cookies. If you use 8 cups, you're going to get 192. And any amount you use in between there, let's say maybe you use 4, you're going to get like what, 96. So again, you're going to get somewhat of a range there, and you're going to get 0 is less than or equal to the C of f function notation there is less than or equal to 192. So that's your range. And the graph will kind of follow that accordingly. Number 24, I think, is a pretty easy problem. You just take the c equals 45x plus 45, and we did this in class, and you make sure that you basically do the table of values like we did in previous problems. On this one, though, just make sure you label the axes just like I did on the review answer key. If you look at the review answer key, it's a fantastic, just labeling. Make sure you basically follow that model, and you'll be great on your test. So I've already started number 26 here. I'm looking at my domain and my range. So you've got to pull the different information from the domain. So if you go in order, the domain, the first domain value, the x value you see is negative 10. It's because it's paired with a 9. And then negative 2. And then 5. And then 9. And then for my range, I have 9, and then 9, and then 9, and then 9 again. So the range is only actually going to be one value. So this is actually your domain and range for that problem. It's a pretty easy problem. Okay, real quick for 28 and 30, those are the ones I want to show you. You need to do 2 things. You need to graph the points appropriately, which we've done in class tons, and you also need to make sure you do the vertical line test. Now remember, here's what the vertical line test is. If you put a vertical line, a straight up and down line, it's not really straight, but it's close enough. If you do a straight up and down line at any point on a graph, if a point hits at any point, if you see a point hits only one time, every time, one time, 0 times, 1 point. Okay, at any point, if you only see 1 point hitting that line, that means it's a function. 0 points is fine. 1 point is fine. However, folks, if you would have, let's say this, ready for this? If you'd have these 2 points hitting the same vertical line, that means it's not a function. So that should help you. Last question, number 31. It says find the range of f of x equals 4x minus 6 for the domain negative 1, 3, 7, and 9. Well, f of x is 4x minus 6 is right here. And the domain values, those are those x values I'm going to choose for x. Negative 1, 3, 7, and 9. They give them to us. And we've got to find the range values. You're finding the y values. All you're doing is plugging stuff in. I do 4 times negative 1 minus 6. That's going to give me negative 4 minus 6, which gives me negative 10. I then have 4 times 3 minus 6. That gives me 12 minus 6, which gives me positive 6. I then take 4 times 7 minus 6. That gives me 28 minus 6, which gives me 22. I then have 4 times 9 minus 6, and that gives me 36 minus 6, which gives me 30. Those are all my range values, but then what I need to do is list out my range in appropriate set notation, which gives me negative 10, 6, 22, and 30. Okay, study hard. Make sure you work hard on this. You should do great on your test. Good luck.